Watch this mechanic hoist a 500-kilogram engine out of a chassis using a single hand on a vertical chain. He isn't straining, he's pulling smoothly, as if the massive block of iron only weighs a few dozen pounds. We have to ask if this ease is the result of raw physical strength, or if he's utilizing a mechanical system that makes the engine's mass manageable. For most of history, biological muscle was the only engine we had. Ancient builders had to rely on the collective brute force of thousands of workers to move massive stone blocks, because human muscle tissue will simply fail once it hits a hard limit of tension. Since our biology has a strict ceiling on the force we can exert, we were forced to invent systems that redistribute weight so it no longer rests entirely on our own shoulders. The solution requires only 3 components: a length of rope, a grooved wheel, and a gravitational load to pull against. Think of it as a flexible lever. Instead of a rigid wooden beam resting on a fixed fulcrum, a pulley wraps that lever continuously around a central pivot point. The pulley functions as a physical ratio. By bending your pulling force around the wheel, it transforms the direction of your effort into a specific mechanical advantage. Let's start with a basic baseline. If you attach a single fixed pulley to the ceiling and tie a 100-kilogram weight to the rope, lifting it still requires exactly 100 kilograms of force from your end. This setup offers no mechanical advantage. The only benefit is directional. It allows you to use your own body weight to pull downward against gravity. The breakthrough happens when you detach the wheel from the ceiling and mount it directly onto the heavy load itself. Now you anchor one end of the rope to a solid ceiling beam, loop it down through the movable pulley on the load, and pull up on the other end. Suddenly, the ceiling anchor is carrying exactly half the physical weight. The tension in the rope equalizes. Newton's third law dictates that the ceiling must pull back with an equal and opposite force. 50 kilograms of the load is supported by the architecture, leaving only 50 kilograms for your hand to lift. By manipulating this equilibrium, we are essentially using the building itself to perform half of our physical labor. We can scale this up by linking multiple pulleys together into what's called a block and tackle. For every segment of rope supporting the load, the required pulling force gets divided by that number. It works exactly like a gear ratio in a machine. A smaller gear turning a larger gear multiplies torque, but it sacrifices speed to do it. Which raises an unavoidable question. If a pulley system gives us all this extra lifting force, what exactly are we giving up in the exchange? The answer lies in the mechanical law of work. If you build a 4-to-1 pulley system to reduce your lifting effort by 4 times, you now have to pull 4 times the length of rope to move that load the same vertical distance. To lift that box just 1 meter off the floor, you have to pull 4 solid meters of rope through the system. A pulley is a currency exchange. We trade distance to purchase the power required to move an object that would otherwise be immovable. This trade-off scales up to enormous proportions. Modern high-altitude construction relies on massive pulley arrays to manage extreme weights where human access is limited. The Romans utilized this thousands of years ago. Their heavy cranes used a human-powered treadmill and a 3-pulley system to hoist 6-ton marble pillars into place. It's the same principle found in complex ship rigging. By multiplying the wooden blocks and looping lines over and over, a small crew controls the immense tension of heavy sails against the wind. We even use them in microgravity environments. On the International Space Station, specialized pulley tracks apply precise resistance to astronauts' bodies, keeping bones and muscles strong without the need for actual weights. But remember, pulleys do not create energy. They simply spread the work out over a longer distance so our biological systems have the capacity to process it. Instead, it is a mechanical payment plan. Instead of paying the full price of a heavy lift all at once, you pay in manageable installments of rope over a longer period of time. Which brings us back to the garage. The single chain that mechanic pulled is woven through a complex block and tackle system, multiplying his effort until his arm is capable of lifting half a ton of steel. These systems provide a way for human intelligence to restructure the requirements of physical effort, allowing us to overcome the inherent limits of our bodies.